Hi everyone, welcome again to another video of SAT Math Explained. Today our topic will be nonlinear equations in the advanced math domain. And this is the last video for this domain, and after this we're going to move on to problem solving, data analysis, and after that geometry. And we should be finished with all these videos by the end of the month of July. And so before we get started, just subscribe, like, and click the bell so that you guys know when I upload. And also if you guys want, share so that you can help other people as well. And let's get started. So this is basically nonlinear equations, just applying everything you know from the algebra domain, just applying it on nonlinear equations, which on the SAT will be, I'm pretty sure mostly, or if not all, quadratic, exponential, square root functions, and absolute value. I don't think anything else pops. Maybe sometimes you'll get cubic or I don't know what it's called, the one with the a polynomial to with the fourth degree, like x to the 4. But overall, the ones that you need to know like deeply are quadratic functions and exponential functions. So yeah, let's just start. So what do you need to know? Like I said, just apply your previous skill to nonlinear equations. Mostly it's going to be just quadratic function and exponential, where you will need to know them in depth. If it helps to know them in depth, you don't need to. Like you could always just use Desmos, but it helps to know like quadratic and exponential, like how to read their equations, which will help a lot. So how do they look? How can I use them, etc. For the other functions, they won't. I don't think they'll ever ask you like specific questions about it, or like this is an equation. What does this number mean? It never does that. That only pops up for quadratic and exponential. So I'm just going to briefly go over it. So I'm going to start with a quadratic. So with the quadratic, there's three forms that will show up on the SAT, and the first one is ax squared plus bx plus c. So basic things to know about this: c is the y-intercept, and that is pretty much all you can get from this. Just that c is the y-intercept. So c is the, I just want to put that, is the y-intercept, and then this can be factored to be in the form of, this can be factored to become a times x minus r1 times x minus r2. And what this is, just r1 is the first root or x-intercept or solution. They all mean the same thing. And r2 is the second solution or root or x-intercept. So yeah, and the a always carries on. The a is always the same because a is just basically how narrow or wide the quadratic is. And then the final form is called vertex form. It is a times x minus k squared. X minus k squared. Oh, sorry, I made a typo. It's x minus h squared plus k. And basically this one is useful because the coordinate h comma k. So make sure to like, if you realize it's supposed to be minus h. So if it's negative, if h is negative, you make it positive. If h is positive, you make it negative. And then the point is h comma k. That is the vertex. And the vertex is basically just always the minimum or maximum. So another good way to remember this. Now another important thing to note is that basically the what's it called? A determines if it's up or down, if it opens up or opens down. So if A is positive, it opens up. A is greater than 0. A is greater than 0. And this one is A is less than 0. If A is greater than 0, so right here, A is greater than 0, so A is positive, you get a local minimum. If A is less than 0, you get a local maximum. And so the last thing you should know for quadratics is basically that when you're in this form, another thing that helps, I forgot to mention it, it's not just the y-intercept. You can also get the vertex from this form. You can get the x value of the vertex through doing negative b over 2a. So that this will give you basically the x value of this point. So if this was, let's say, x comma y, this thing would give you x, negative b over 2a. So this, the coefficient of x divided by 2 times the coefficient of x squared. Okay, so another important thing to note is polynomials in general. So a polynomial is anything with x to the power of something, so x to the power of a, let's say. So that includes anything x squared, x cubed, x to the 4th, anything, and so on. So basically, if it's even, so something like x squared, x to the 4th, x to the 6th, if it's even, that means that it's the ends of it will always go in the same way. So like for x squared, they're either always going to positive infinity or they're going down to negative infinity. They never, like, one goes up, one goes down. They're always going the same way, left and right. And then let's say the same thing for like x to the 4. X to the 4 is going to look like it comes here and then like that. So they still both go the same way. Although it's going to cross more times, it's going to cross the x-axis more times, they're going to go the same way. And wait, I drew that wrong. It's gonna be like this. But yeah, you get the idea. They go the same way anyways, no matter what. And to the 6, it would be the same thing, but it will touch the x-axis 6 times instead. And then if you have an odd polynomial, so that's like x. I mean, you could count x to the power of 1, x cubed, x to the 5th, and so on. They're always going to go opposite. So one of them is going to go to positive infinity, the other one to negative infinity. So like imagine x cubed would be like this. Yeah, x cubed would be like that, or maybe like this, like that. Always going. This one's going up. This one's going down. This one's going up, down. This one's going up. Same thing. They're always going in the opposite directions. And even if you have like x to the power of 1, like imagine a linear line, it's always going. This side is going to positive infinity. This side's going to negative infinity, or the other way around. This side's going to negative. This side's going to positive. And the last thing you should know is just know the basic things about exponentials. So let me just erase this. Okay. So for exponential functions, it's important to know the main form. So the main form is y equals a times b to the x. So it's important to know like what each constant means. So a is the starting value. Starting. B is the rate at which it changes. Rate of decay, or I'm just gonna put rate, but it's the rate of decay or growth. So basically how B works is B is either equal to 1 plus the rate, or B is equal to 1 minus the rate. So if it tells you that it's exponential decay, so like it tells you every month it goes down by 5%, let's say. So right there, the rate would be 0.05. So that's another thing to know. You need to know how to convert percentages to decimals. So anytime you have a percent, like 5%, if you want to take it to decimals, you just divide it by 100, and you get it in decimal form, 0.05. 0.05. So basically, if it's exponential decay, you do b equals 1 minus that number. If it's growth, you do 1 plus the rate. So yeah, I think that's all you need to know about exponentials. Let's move on to the other tips, like I said. Okay. So also the just same thing, just continuing from part 3, just in more specifically, just be able to interpret word problems, graphs, equations, because almost every question will be for this specific focus skill. It's either going to be interpret an equation. It's going to give you an equation. What is f of 4? What is f of 5? Something like that. And or sometimes it'll give you like or graphs also. Sometimes it gives you a graph. Either the graph is the answer option, they give you a graph, which one's the equation. So it's important to know that. And sorry, I meant table. So you just need to know how to interpret word problems, graphs, and tables, because they will all show up. And especially word problems, though, that's like the most prominent way that these questions are tested. They're going to give you a word problem, a scenario, and they're going to either ask you to give them an equation, going to give you an equation, then ask you what does this number represent, or something like that. Or give you an equation, or tell you after 5 years what would be the number. And also, some questions, although it's not as much as like these other tips, some questions are going to test like transformations. So either most of the time it's going to be like a transformation on the y-axis or the x-axis. So it's going to be like you have this equation, this other equation is plus 12, solve for this thing, something like that. Like it's 12 to the right, let's say, solve for this constant or something. So that's all that for what you need to know. If it's confusing right now, it'll simplify more when we get to the examples. But let's move on. So how do you solve these type of questions? Again, these do vary, but the most important thing is just identify the type of function. Is it quadratic? Is it exponential? Is it absolute value? And so on. Then just understand what the question is asking for. What does it want from you? Does it want you to give it a graph, solve for a constant, interpret a number, or interpret a word problem? And then just use the appropriate methods. It's really difficult to like give you a concrete method because the questions will vary. And use Desmos will all be almost, I think every single question on these examples today can be solved using Desmos or assisted with Desmos. And if you want to solve it by hand, it's also useful to just learn how to use Desmos to check your answer. Of course, if you have time. So let's just move on to examples. And today, these examples are a bit shorter, so instead of the usual 2 easy, 2 medium, 1 hard, I'm going to do 3 easy, 2 medium, 1 hard. And again, please always remember to try the question on your own. Like pause the video, try the question, then watch my explanation, because it never helps to watch someone explain something. Like it doesn't help watching someone solve the problem. That just gives you a false sense of understanding. And yeah, so let's start with the 3 easy. The first one just tells us if x squared minus 6x plus 3, if f of x equals x squared minus 6x plus 3, all divided by x minus 1, what is f of negative 1? So for this one, you could technically plug it in, all that, but it's really a lot easier to just go ahead and just plug it into Desmos. So does it show for you guys? Okay, yeah. So if you want, you could just, there's 2 ways to solve this actually with Desmos. Just plug it in, x squared minus 6x plus 3, put parentheses so you can do like everything above on the numerator. Then I put x minus 1. And then just look, so f of negative 1, when x equals negative 1, so x equals negative 1, sorry, x is on the left side. When x is negative 1, it is equal to negative 5. And you saw how I was tracing, which that wasn't very smart. You could just put x equals negative 1, it draws you a line, you click. So negative 1 comma negative 5, and the answer would be A. Or another way to do it is you put f of x, like you literally just write exactly what they give you. You put f of x equals this, equals the equation, put f of negative 1, it gives you the answer right here. F of negative 1 is equal to negative 5. And that is it for the first question. The answer is negative 5. As usual, if you have any questions, just let me know in the comments. And let's move on to the next question. So this one gives us a graph, and it tells us that the quadratic function graphed above models a particular measure of plant diversity as a function of the elevation in a region of Switzerland. So it's basically comparing elevation to plant diversity. It's comparing it to the elevation. So according to the model, which of the following is the closest to the elevation in meters at which the plant diversity is greatest? So this one actually doesn't need Desmos. I don't know how you could use Desmos on this. Desmos is useless. But basically, we want to see when is the plant diversity greatest. So first thing, look at the axes. This one's elevation. This one is plant diversity. So we're going to be looking at the y-axis. So just when is the y-axis at the highest point? So you can see this is the line. And so just the highest point is about right here, which is at the vertex. So honestly, it's just visual. So then you look here, it's between 1,000, 1,500. It's in the middle, so it's 1,250, which is answer option C. And that is it for this question. For the easy question for this, it's pretty simple. It's mostly like most of them you could just do it in an instance, either in your mind or in Desmos. And this one asks, what is the y-intercept of the graph shown? So this is an example just applying the linear. From the algebra domain, you learned the y-intercept is when x is 0. So when x is 0 right here, you just draw a line if you want. It crosses the y-axis at point x equals y equals negative 5. So you could automatically cancel a because you know the y-intercept is when x is 0. So it can't be a because x is negative 1. And then you just look at the graph, you know that the answer is 0 comma negative 5. This one. So that's it for the easy questions. You guys saw how we could go through it very quickly. And now let's just move on to the medium questions. So for the medium question, we're given, it looks like an exponential. It's in the form like a times b to the x, except they use different letters, but that is okay. So it tells us that the function fs above models the annual salary in dollars of an employee n years after starting a job, where a is a constant. If the employee's salary increases by 4% each year, what is the value of a? So we know that this is in the form, it's going to be confusing because there's an a right here, but basically it's in the form a times b to the a times b to the x. But so a is the starting value, so it tells us, we can see he starts at 38,000. So b is the rate, or the number. So in our example, a is going to be the rate. So if the employee salary increases by 4% each year, so the only thing that's missing from this is a, the rate, which is what they're asking for. So like we said in the what to know, the rate is equal to 1 plus the rate or 1 minus the rate. So not the rate. So sorry. A right here, or b in our general equation, is equal to 1 plus the rate or 1 minus the rate. So here it says that it increases by 4% each year, so it would be plus, so we're choosing this one. And then we want to change 4% to a decimal. So 1 plus 4 over 100. If you want, you can put this in Desmos, and that is equal to 1.04. And that is answer option C. That is it. So let us move on to the second medium question. This one tells us which of the following could be the equation of the graph shown in the picture. So I see that this is not a quadratic, but it's in the form that's the factor form basically. Yeah, this is in the factor form. It shows you all the roots. So this is one of the root, this is the second root, this is a third root. So we know that the roots right here, if it's x minus 4, just to remind you guys, that means the root is at x equals 4. It's like the opposite. Negative becomes positive, positive becomes negative for quadratics and for polynomials. So let's just, first thing, just look at the graph and let's determine all the roots, because all of these are in the root form for the polynomial. So this one, it touches the x-axis at x equals negative 5. That is one of them. So I'm just going to put it off to the side. So x is equal to negative 5. Right here, it touches again at x equals 0. So x equals 0. And then it's right here again at x equals 4. X equals 4. Yeah. So then it asks us which of the following could be the equation of the graph shown below. So at first, you might you might think, okay, first thing, let's just find the ones with these roots. So the roots are going to be, because it's x equals -5, so we're going to get x plus 5 in parentheses. And then this one x equals 0, so we just have x. And if you looked at the question, all of them have x in the front, so we're good with that. And then this one x equals -4, x minus 4, sorry. So we're looking for x plus 5, x minus 4. So this is one of them, x plus 5, x minus 4. This is another one. These two on the bottom are wrong, because it's the opposite. So these two, I'm going to do it in red. These two are wrong. So then we're left with these two. We have one of them they're the exact same thing, but this one is x plus 5. This one's x plus 5 squared. So right here, it's important to note that if you look at this, you see that it starts here. It's going to negative infinity, and the right side is also going to negative infinity. So what does that tell us? That tells us it has to be an even function. So if we like multiply all the x's, we should get x to the power of an even degree. So for the first one, for this first one, you multiply, you get this is x to the 1, x to the 1, x to the 1. So this is going to be x cubed times something, and there's going to be a coefficient in front of it, but it's like ax cubed. And that is an odd function, so it can't be both ends can't be going to the same infinity. They can't both be going to negative infinity. So then let's look at this one. You have x to the 1, x to the 1, and then this one, there's an x squared on it. So for this one, you get a times x to the 4th, which makes sense as which would make sense as an even function for this one. So if you have any questions, just let me know, because this one might be confusing. I also want to point out there's another way to solve this technically. Like, you don't have to know about even and odd functions, but you could have known. Let me just clear up the graph. But basically, you could have known that if it doesn't cross the x right here, you see that this x-intercept, it doesn't cross the x-intercept, doesn't cross the x-axis. So right here, the x equals -5, it just bounces off. It touches that and bounces off. So when that happens, it's always going to be, like in our case, it's going to be x plus 5 squared. But it has to be an even degree. So it could be squared, it could be to the 4th, but you just have to know that it has to be to an even degree because it only bounces off. But for x equals 0, let me do that in a different color. For x equals 0 and x equals 4, it crosses the x-axis, so that means it has to be an odd number. So that's why you get x to the power of 1 and x minus 4 to the power of 1. Yeah, so that is important to note. And another way you could technically solve this with Desmos, let's say you don't know any of this. You don't know about you don't know about the even and odd degrees, you don't know about even and odd functions. You could just plug each one of these into Desmos until you find the right answer. Like until you find one that looks like this. So I'm just gonna go show that real quick, because I just want to make sure that there's an important mistake I don't want you guys to do. Not a mistake, but a tip. So let's say I wanted to go graph, I'm just going to graph the correct one for now. So let's say -1/10. You guys can see it, right? Yeah, okay. So let's say you graph -1/10 times x. You graph the equation for b, this one, which we said was correct. So times x minus 4 times x plus 5 squared. So right here, just to make sure, because this might not look exactly, because some of them might look similar, just in case, you could come here and you could change the bounds to look like this. So this one, -8 to 8. So you can change this. -8 to 8 for the x-axis. And the y-axis goes from 100 to -100. -100, 100. And by the way, I found this by clicking on like the toolbox right here. It says graph setting. And then you look at this, it's the exact same line that's shown in the thing, which might help you. And yeah, that is it for this question. And now we're going to move on to the final hard question. And so this one tells us that function f is defined by f of x equals -a to the x plus b, where a and b are constants. In the xy plane, the graph of y equals f of x minus 12 has a y-intercept at 0, -75/7. The product of a and b is 320/7. What is the value of a? So this question might look confusing, but initially you just look at it. They gave us a line with two constants, so that's confusing. How are we supposed to use it? But then they tell us that they give us another line with it's this line minus 12. So -8 to the power of x plus b minus 12 at the end, and then it gives us a point. Then you can notice this point has x equals 0. So automatically I see that if you plug in x equals 0 for x, you would get -a to the power of 0, which would be -1, and then you would be able to plug in b So that is what we're going to do. So first thing, we're just going to try to plug in this point into this equation, y equals f of x minus 12. So y equals f of x minus 12 is y equals -a to the x plus b minus 12. So then let us plug in this point, because this point is technically it is a solution to this graph. So if it's a solution, we can plug it in normally. So negative 75 over 7 is equal to negative a to the power of 0 plus b minus 12. So now you see, after they gave us the coordinate, we're able to remove a. So a to the power of 0 is 1. 1 times negative 1. You get negative 1 plus b minus 12 equals negative 75 over 7. So this is great because now we only have one constant, and now we can just solve for it. So we can start solving, although it tells us to solve for a, we can start by solving for b, which will help us in solving for a. So for this one, negative 1, negative 12, it's negative 13. Then I'm just going to, so negative 13 plus b equals negative 75 over 7. 7. And so I'm going to add 13 to both sides, plus 13, plus 13. B is equal to negative 7. I'm just going to do this in decimals real quick. So negative 75 over 7. Negative 75 over 7 plus 13. And so I just want to show you guys a tip that might help you guys. So basically, if you put it into decimals and it gives you like a decimal, if you click right here next to where you inputted the expression, you can click this thing, which is like two squares with a line in between showing like a fraction, and it'll give you the answer in a fraction, which is easier for me. I don't know about you guys, but if it's easier for you, you can just make it into fraction, or the other way around, you can turn it into decimals. I don't know why it made a line, but okay. So then b is equal to 16 over 7. So then, how can we find a? Because we only have one point, so it's hard to find a because we only have the y-intercept. So whenever we plug it in, a is going to disappear because a to the power of 0 is 1. So that's why they gave us another line, not a line, but another equation. The product of a and b is 320 over 7. So what does that mean? That means that a times b is equal to, what was it? Sorry, 320 over 7 is equal to 320 over 7. So now, because we solve for b, we can just plug in b and then solve. So a times, we just plug in the number for b, 16 over 7, equals, okay, it's not letting me write. Equals 320 over 7. 320 over, okay, 320 over 7. So then from here, you can use the skills you learned in, that is 320. You can learn the skills you learned in one of the first videos of the algebra domain, which is how to solve for one variable. And so then you could just do divide both sides. So divide both sides by 16 over 7. Divide by 16 over 7. Divide both sides by 16 over 7. So then just put this into the calculator. 320 over 7 divided by 7. And for me, it's just better to put it in, for me, it's better for my brain to put it in parentheses. Divided by 16 over 7. And then you get 20. So a is equal to 20. And that should be an answer option, I hope. Oh, so it's like that. And yeah, I'm sure of the answer, but I'll just take a moment to check it. So yeah, that is the correct answer. 20 is the correct answer. And yeah, so that is it for this question. So if you guys have any questions, just let me know. I know this one might have been a bit confusing. But yeah, so that is the end of this video about that is the end for this video about nonlinear equations. So if you guys have, like I said, if you have any questions, put it in the comments. I'll make sure to answer. And after this is that, we're done with the advanced math domain, which is great. And yeah, we're done with the advanced math domain. We're gonna move on to problem solving and data analysis starting tomorrow. And so before you guys leave, just subscribe, like, click the bell, and if you guys want, share to make this channel reach more people. And thank you for watching, and bye.